Alright, here's your warm-up today. Please push pause and allow them about 3 to 4 minutes to complete this. Thank you. Alright, on this warm-up, I just kind of want you to first off realize these are not inverse problems. We do not see the inverse notation, okay? So in this problem we are actually looking for theta for every single time that cosine is 1/2. If you look at a unit circle, okay, cosine is the x value. If I come over here and I see 1/2 is right there, and 1/2 is actually down here. So there's actually two places where cosine is 1/2 on the unit circle. Alright, and now if I wanted to look at positive angles only for right now, I would say that this one right here would be pi over 3, and then this one down here would be 5 pi over 3. Alright, so that means we have two answers, pi over 3 and 5 pi over 3. Okay, now let's do this next one. Sine is the y value on the unit circle. I'm looking for the y values that are negative square root of 2 over 2. Okay, so on the unit circle, there we go. Negative square root of 2 over 2 for the y values is going to be at the bottom of your graph, right? Because y is negative down. Okay, so there's one and there's one, right? So what angles are those? That would be 5 pi over 4 and 7 pi over 4. So those are our answers. Theta equals 5 pi over 4 and what was the other one? 7 pi over 4. There we go. Alright, today's notes. You need to keep out your unit circles, guys. Alright, solving trig equations. This is a little bit different than what we have been doing. Okay, a basic trig equation, just like on the warm-up. We have our trig function with an angle inside of the parentheses will equal a value. Now, a trig function, remember, that can be anything. That could be sine, okay, that could be cosine, tangent, whatever one that we're working with. Okay? What you need to know. First thing that we need to kind of realize is that cosine of pi over 6 equals square root of 3 over 2 is the exact same thing as cosine of 30 degrees equals square root of 3 over 2. And it's the exact same thing as cosine 30 degrees is approximately 0.87. Okay, and that's just the decimal value of this fraction, right? Okay. And then we can also say that cosine of 0.52, which is the radian value, okay, so it's the same thing as, roughly anyways, as pi over 6, alright, is approximately 0.87, alright, which is, again, square root of 3 over 2. So all of these things actually mean the exact same thing. So we kind of got to realize that as we go through these notes. Alright. Now if we go backwards, in other words using the inverses, the inverse of 0.87 is approximately 30 degrees and 0.52 radians, or approximately pi over 6 radians, right? Okay. Don't worry, I'm getting to something. Okay. So how to solve a trig equation. We're going to have some steps involved here. Okay, so I believe there are 4 of them. Okay. And I'm just going to kind of let you guys write them down as we go. Okay, just to kind of save some time, I'm going to throw up these notes. Alright, first thing you want to do is get your trig expression alone. Okay, so in other words, we're going to get sine by itself. Alright, the next thing you're going to do is determine which 2 quadrants theta can be in. We're going to use the sine value and draw a picture. Okay, now sine means positive, negative, not sine as in the graph or in the trig function. Okay. Number 3, we're going to be using an inverse trig function to help us find the angle. So on the calculator, we're going to be using the inverse function. Now, this is where we have to know what quadrants an inverse will actually land us in, so we know what we're given whenever we're looking at the calculator. And then lastly, we're going to use the quadrantal measures to find the other angles. Okay. Now notice that we're mainly using 180 and 360, which is on the x-axis. Okay, and we're actually going to be using a value for pi now because we want roughly the actual values and the angles. Okay, of 3.14 and 6.28. All right. Remember, 6.28 is the same thing as 2 pi. Give you guys just a second to copy this down. Remember, you can always pause this if you need more time to copy this down. Alright, let's work one and kind of see what all is going on, okay? First off, I need you guys to kind of pay attention to this statement. This statement means we are working in degrees. Alright, and I'm going from 0 to 360. That means all positive degrees on one cycle of the unit circle, okay? That also means that you need to get your calculator, hit the mode key, and switch it to degrees real fast. Alright, looking at our problem. Step 1 says to get our trig function by itself. That means nothing with it. It means I shouldn't see a 2 times sine theta or a sine theta plus 5 kind of thing. I should only see sine of theta equals. Alright? And I have that, so check. Step 1 is good. Number 2 says determine which 2 quadrants theta can be in. Well, sine is the y value, right? It's the y value. And I'm looking at a negative value here. So where is y negative if I actually drew a graph? Where is it negative at? Well, it's negative in the 4th quadrant and in the 3rd quadrant. Alright, so there's actually 2 different places that it's going to be negative at. Okay, so that means we're going to have to find 2 different angles, 2 different thetas. Okay, Now we can use the inverse to help us find one of them. So sine inverse of negative 0.7 equals theta. Okay? Now, if you remember, the inverse of sine gives you answers in the first and fourth quadrant. So whatever we plug into our calculator is going to give us this answer right here. Okay? Now when you plug in inverse sine negative 0.7, you should get negative 44.43. Okay? Now what's really nice about this is that these right here are reference angles, right? Now my drawing's kind of bad, but if this reference angle is 44.43, that means that this reference angle is also 44.43. So I can actually write that in, 44.43, just like that, degrees. Okay. Now I need to find this angle and this angle, because remember I want both positive angles. And we have to be able to figure this out, what we need to do. The smaller angle, if you kind of think about it, a straight line is 180 degrees. And then I just have a little bit extra, 44.43 degrees extra, right? So all you have to do is add 180. So theta will equal 224.43 whenever we add 180. Now, this angle, if you kind of think about it, all the way around is 360, and we're using up 44.43 degrees of it. So all we need to do is subtract 360 from 44.43, and we'll get our answer. And that ends up being 315.57 degrees. Alright, and that's it. That's all you have to do. Okay, we're just going to kind of go through a few of these, make sure everyone kind of gets it. So, just kind of keep up. Okay, cosine is the x value. I'm looking at a positive value. So I'm going to draw my graph. The x values are positive on the right side of your graph, so over here. Just like this. Okay. I need to take the inverse, so cosine inverse of 0.42 to help me find one of my angles. Whenever I do this, I get 65.17 degrees. Okay? Now, that actually happens to be one of the angles that I need to find, is this angle. I also need to find this angle, right? Well, I also know that these are reference angles, and that this angle right here is 65.17 degrees. So all I need to do is subtract 360 from it, and I will find my other angle. So theta is going to equal 65.17 degrees and 294.83 degrees. And it's always kind of a helpful kind of thing to do. Look at your angle and make sure that your angle makes sense to be in the quadrant that you're in. In other words, this angle right here is in the fourth quadrant. Fourth quadrant goes from 270 to 360. Am I in that little section? Yes. Okay, it's just like a little mental check. Make sure you're in the right spot. Okay? Okay, cotangent. Now, we cannot do cotangent inverses, so we need to change this to a tangent. Remember, whenever you change to tangent, all you need to do is flip your value. It doesn't actually flip your angles, and that's why this can work. So I'm going to change this to tangent theta equals -1 over 0.3. Now, it's okay to have a decimal in the bottom because we are plugging this into the calculator anyways. It's going to fix itself. Okay? It's going to do all the work for us. Alright, let's kind of think about this. The charges over here is plus plus, negative plus, negative negative, and positive negative, right? Which two quadrants would a fraction, which tangent is, right, is y over x, which a fraction would turn negative? It's where one is negative and one is positive, right? Okay. So I'm looking for this angle and this angle. Those are the two angles that I'm looking for. Okay, so let's kind of work through this. I need to find out what the inverse of tangent is of -1 over 0.3. Okay, whenever I plug that into my calculator, remember tangent's in the first and fourth quadrant, so it's actually going to give me this angle right here, which is -73.3 degrees. Okay? Well, that means that this right here is 73.3 degrees. All I need to do is subtract 180 to find out what this is, which is, let's see, that is 106.7 degrees. Okay. And then same kind of thing that we did over here. We need to just subtract the 360 from it, which ends up being 286.7 degrees. Whoops. A little off the screen there. Okay. Hopefully I wasn't off the screen for too long. Alright. Got a few more of these to go. I'm going to start speeding up a little bit. Cosecant is the flip of sine. So I'm going to have sine of theta equals 1 over 14. Okay. Sine is a y value. This is a positive value. Y values are positive up. So it looks like that, right? Man, my reference angles are bad. Okay, so I need to take the inverse to help myself out. So inverse sine of 1 over 14. Okay, which gives you 4.10 degrees. Now I also need to find out what this angle is, right? Well, this right here is 4.10 degrees. Okay, so all I have to do is subtract 180 from it. So theta equals, okay, so theta is going to equal the 4.10 degrees and 175.9 degrees. Okay, and number 4, if you notice, this is the first time we have other things with our trig function. So we need to get rid of the 6 and the 5. Okay, first thing you want to do is subtract 6 from both sides. So you have 5 secant theta equals -6. Divide by 5. Divide by 5. Okay, and then we need to change secant to cosine. So it's going to be cosine of theta equals, okay, we need to flip these over, so it's going to be negative 5 over 6, just like that. Okay, cosine is negative on the left side of your graph, right? I need to take the inverse to help myself out, so cosine inverse of negative 5 over 6 equals theta. Okay, that's going to give you this angle right here, which happens to be 146.44 degrees. Now, this one's a little bit more tricky because we need to find out what this reference angle is to be able to figure out what this reference angle is. If that makes sense. To be able to figure out what this reference angle is, all you have to do is subtract 180 from this. Okay? Alright, and when you do that, you get 33. So this angle right here is 33.56 degrees. Okay? Now, again, if this reference angle is 33.56, that means that this angle, this reference angle, is 33.56. I know that a straight line is 180, so all I need to do is add 33.56 to it. And you get 213.56. So your final answer is going to be theta equals 146.44, which comes from that first line, and then 213.56 degrees to your second angle. All right. Number 5. Okay, let's get cosine by itself. Okay, so we need to move the 10 over, right? So it's going to give you a negative 7 equals 6 cosine of theta. Divide by 6, divide by 6. Let's go away. So I'm looking at that. This is a negative cosine, so if I drew a graph, I would be over here, right? Negative cosine kind of thing. I need to take an inverse, and I do see a problem. Hopefully you guys do too. So cosine inverse of negative 7 over 6 equals. Now whenever I plug that into my calculator, you should get an error. You get an error because this right here, okay, what is that actual value? You actually plug it in. Negative 7 divided by 6. It's roughly, what was that, negative 1.16 repeating. Okay? And kind of think about your cosine graph and sine graph. Okay? They kind of go along just kind of like that, right? Where this is 1 and this is negative 1 with our waves. Okay? This is below negative 1, which means it would not be on our graph. Alright? Which means there is no solution to this. Okay? It's not on the graph, so I can't actually get an angle and a value. Okay. Number 6. Let's move the 9 over and then divide by 6. So cosecant theta equals 9 over 6, which is the same thing as 3 over 2. Okay, cosecant's the flip of sine, so it'd be 2 over 3. Now 2 over 3 is less than 1, so I can actually work this. So I'm going to draw my graph. Sine is positive, so I'm up here. Right? Inverse of sine of 2 over 3. which gives you 41.81. Remember, you gotta kind of keep in mind what quadrants an inverse will give you. Okay, sine is in the first and fourth. It gave me the first quadrant, which happens to be the angle that I need. I also need this angle. Now remember, these are reference angles, so this right here is also 41.81 degrees. So all I need to do is subtract from 180, and I got my answer. So theta equals 41.81 degrees and 138.19 degrees. Okay, so that's degrees. Let's do this in radians now. Okay, so what I want you to do is hit your mode key and switch to radians. Two important radians to know because we're actually using values. Pi, we're going to be using 3.14, so that means 2 pi. We're going to be using 6.284. Remember, these are very, very important because we've been adding, subtracting by 360 and 180. Okay, and this is the same thing as 180. This is the same thing as 360. You'll notice that everything we're about to do is the exact same, but we're using radians now. Okay. First step, tangents by itself. Draw my graph. Negative tangents in the fourth quadrant and second quadrant. I need to take the inverse. Alright. And that's going to give me this angle right here. Now if you notice that this radian is very small, it's negative 0.98, right? But that kind of makes sense because these values right here, an entire pi is 3.14 and an entire 2 pi is only 6.28. So I should be getting small numbers. Okay. Well, if this is negative 0.98, that means this is 0.98 as well. Okay. Remember, reference angles are technically positive. I'm only writing a negative because that's what we got in our calculator. Okay. Alright, so I need to find this angle right here. Alright, which I know a straight line is pi, so all I need to do is take 3.14 and subtract 0.98. Okay, so, we're using x now instead of theta, that's fine. So x equals, alright, and that is 2.16. And then I also need to find this angle right here. So I just need to subtract by 6.28 and you get 5.3. Notice I don't have degree signs up here because these are radians. Alright, cosecant. It's a flip of sine. So I'm going to have negative 1 over 1.4. Okay. Negative sine values are going to be in the third and fourth quadrant because sine is y. Y values are negative down, right? So I'm going to need to find this angle right here and that angle right there. That's my goal. Alright, to do so I need to take the inverse. So sine inverse of negative 1 over 1.4. Okay, remember sine is going to give you a negative angle right there. Alright, and that's going to be negative 0.80. Okay, which means that this is 0.80 over there in that reference angle, which is going to help me find these. So it's going to be x equals, okay, to find this one I need to add 3.14. So you get 3.94. And over here I need to subtract 6.28, which gives you 5.3. 4, 8. 4. Alright. And again, if I'm going too fast, you can always stop the video, pause it, back up, rewatch it if you need to. Alright, last two questions of the day, guys. Last two questions. Okay. Get cotangent by itself. Move the 5 over, divide by 4. So cotangent of x equals 5 over 4. You need to switch this to tangent. So tan of x equals 4 over 5. This is a positive value. So whenever I draw my graph, positive tangent is in the first and third quadrants. I need to take the inverse to help myself out. So tan inverse of 4 over 5. Okay. That's going to give me, what is that going to be? 0.67. Okay. That also means that this right here is 0.67. So x equals 0.67, and then how do you get this one again? This entire angle. So straight line is 3.14, and then I have that little bit of extra, right? So just add 0.67 to it, and you get 3.81. Okay, last one. Get sine alone. Move the -2 over, so that gives you 10. Divide by 9, divide by 9, okay, sine x equals 10 over 9. This right here is greater than 1, so that means there is no solution. Alright, you guys are going to have a practice worksheet to do to kind of work through your problems, and good luck, and I hope to see you soon.